with us. With all the knowledge you possess, we are sure that you will add value to our learning.
Definitely, Reena.
Let's get started. Click Next to proceed to the next screen. With the help of this course, you will be able to explore the following topics: material structure of steel, heat treatment of steel, TTT diagram, CCT diagram, heat treatment techniques. Click Next to proceed to the next screen. By the end of the course, you will be able to explain the microstructure of various phases of steel, describe the various phases in heat treatment of steel, explain the phase transformation kinetic of eutectoid steel through TTT diagram, describe the phase transformation kinetics of hypoeutectoid steel through TTT diagram, describe the phase transformation kinetics of hypereutectoid steel through TTT diagram. Explain the continuous cooling transformation diagram. Describe the various heat treatment techniques. Click Next to proceed to the next screen. We shall begin the course by understanding what the material structures of steel comprise of. Material structures can be broadly classified into three types, namely macrostructures, microstructures, and crystal structures. Macrostructure is the gross structure of a material as visible to the unaided eye or at very low levels of magnification. Microstructure is the structure of a material as revealed by microscopy. Main structural information which are to be taken into consideration are microstructure and crystal structure. Click Next to proceed to the next screen. Structural information of steel can be estimated through a pictorial diagram called phase diagram. Phase diagram is equilibrium diagram of different phases appearing at different temperatures, and if we change the composition, phase fraction would change as well as different phase might appear. Steel is a family of iron carbide, alloys and other alloying elements like manganese, silicon, chromium, vanadium, molybdenum, etc. Taking a look at the iron carbide phase diagram, we can observe that at 0.8% carbon above A1 line, steel is at austenite phase and has distinct microstructure or grain structure. On cooling below A1 temperature, it transforms into 100% pearlite, which is a phase mixture of alpha iron and cementite. Cooling a composition less than 0.8% carbon above the A3 line structure would be different, as we would come across to pro-eutectoid ferrite at austenite grain boundary and pearlite in rest of the grains. Hence, it is evident that if we change the composition, structure would change accordingly. Click Next to proceed to the next screen. As we have previously seen, microstructure of steel varies at different phases. Let us now understand this in detail by clicking on each of the tabs. Austenite grains. Austenite is an interstitial solid solution of carbon in iron having FCC crystal structure. Its microstructure is usually large-grained, depending upon microalloy addition. Ferrite grains. Ferrite is an interstitial solid solution of iron and carbon having very low solubility and its crystal structure is BCC. Austenite grains. Austenite is an interstitial solid solution of carbon in iron having FCC crystal structure. Its microstructure is usually large-grained, depending upon microalloy addition. Ferrite grains. Ferrite is an interstitial solid solution of iron and carbon having very low solubility and its crystal structure is BCC. Pearlite. Pearlite grains have lamellar structure of alpha ferrite and cementite, where dark lines are cementite and white regions are alpha ferrite.